Hello and welcome to this online lecture about assigning oxidation numbers. So oxidation numbers are kind of like a chemistry bookkeeping to try to keep track of what the electrons are doing in atoms and ions of compounds. The most important thing to understand is that although they sometimes directly correlate to electrons and charges, they don't always do so. So it's more like just kind of a way to try to figure out what's going on in terms of electrons, even when it's not always a direct correlation. Um, Basically, what you're going to learn in this lecture is a set of rules that chemists use to assign oxidation numbers to the elements in a compound. I'm going to go through the rules one by one, showing you an example for each rule, and then I'm going to walk you through kind of like the procedure you're probably going to want to follow when you have to assign oxidation numbers to the elements in a compound. By the end of this video, you should be able to take any compound that I give you and figure out what the oxidation numbers of all of the elements in that compound are. So let's get started. We're going to start with the first rule, and that is that the oxidation number for an atom in its elemental form is always 0. So the oxidation number of an atom in its elemental form is always 0. So what does that mean? That means that anytime you have an element that you're trying to assign oxidation numbers to, the oxidation numbers of the atoms in that element are going to be 0. So elements can look different ways. Like you could have just iron by itself, that's an element, and its oxidation number would be 0. You might have a diatomic like hydrogen or oxygen, and when it's in its elemental form like this, molecules of oxygen, molecules of hydrogen, their oxidation number is 0. You might have something like sulfur, which forms complexes of 8, many elements like 8. But since all 8 atoms that are bonded together are sulfur, their oxidation number is 0. So anytime you have an element, which is something made up of all the same type of atom, those atoms have an oxidation number of 0. So that is the first rule. Let's look at the second rule. The second rule is that the oxidation number of a monatomic ion is the charge of the ion. So the oxidation number of a monatomic ion equals the ion's charge. I'm going to scoot this down a little bit here. So if you have a compound like sodium chloride, NaCl, sodium chloride is made of 2 monatomic ions. There's the positive ion sodium, and there's the negative ion chloride. Those are monatomic ions because they're ions made of just one atom. And you know that the charge of sodium is +1 and that the charge of chloride is -1. And so that means that sodium's oxidation number is +1 and chloride's oxidation number is -1 because the oxidation number of monatomic ions equals the ion's charge. So you learned in the first semester how to find the charges of these ions. That charge is the oxidation number of a monatomic ion. So that's the second rule. Here's a third rule. It has to do with group 1 and 2 metals. Oxidation of all group 1 metals. This kind of follows the second rule. Is +1. So the oxidation number of all group 1 metals is +1, and that makes sense because you know that all of those metals form +1 ions. And the oxidation oxidation number of all group 2 metals is +2. So anytime you see magnesium in a compound, you know its oxidation number is +2. Anytime you see lithium in a compound, you know its oxidation number is +1. That's in a compound, not by themselves, because if they're by themselves, their oxidation number is 0. So this is only when they're in a compound. Only when they're in a compound as an ion. Okay, so the fourth rule has to do with hydrogen. The oxidation number of hydrogen is almost always +1. When it's in a compound. So if you see hydrogen in a compound, its oxidation number is almost always +1. The only exception is if the hydrogen's with a metal. And when it's with a metal, it's -1. So anytime you see hydrogen in a compound, it's almost always going to be +1. And the only exception that rarely happens, to be honest, is when it's with a metal, hydrogen with a metal. At that point, it's going to be the ion hydride, and it's going to be -1. So hydrogen's a pretty easy one. It's almost always +1. So next we're going to do oxygen. So this is rule number 5 now. The oxidation number of oxygen when it's in a compound, again, remember, if it's by itself, it's 0. So oxygen is -2. Now, oxygen is almost always -2. But like most rules, there's an exception to this one as well. And that exception is in the case of it being part of a peroxide. And peroxide is a polyatomic ion whose charge is -2 by itself, but it's O2. So when it's in a peroxide, oxygen's oxidation number is -1. So you have to be careful there. If it's a peroxide, like hydrogen peroxide, then oxygen's oxidation number will be -1 at that point. But it's almost always going to be -2. Now these two rules are pretty important. Hydrogen is +1, oxygen is -2. Those are two really important rules, and you're going to be going back to those a lot. The exceptions that I put on there are very, very rare. Both of those exceptions, you might maybe encounter them very, very rarely. I don't even know if they're going to be in this course at all, to be honest with you. So I put them on there because they do happen, but you might not ever see them in this high school class. So, okay. Next is a rule for fluorine. The oxidation number of fluorine is always -1. So fluorine is always -1. Okay. Now so far I've given you kind of just like little rules for specific elements. Now we're going to get into the rules that you use when you're dealing with the elements that are in a compound. The first one of those is that the total, I don't know what I was doing there. The total oxidation of a compound must be 0. So in other words, if you add up all of the oxidation numbers in a compound, you have to get 0. And so we can use that to figure out some of the oxidation numbers that we don't have rules for. And I'm going to show you that in just a second. And then a rule that kind of goes along with that, and this is the last rule, is that the total oxidation of a polyatomic ion must equal the ion's charge. Okay, so if you have the compound hydrogen sulfide, which is H2S, you know hydrogen is, oxidation is +1, and there's 2 of them, so that's +2, 1 times 2. And so to get 0, because the total oxidation must be 0, this sulfur has to be -2. So that's an example of the compound equaling 0. Now let's say I have sodium sulfate. We know oxygen's always -2 unless it's a peroxide, so that gets us -8. The charge of the sulfate is -2. So I need something -8 that gives me -2. So 6 minus 8 equals -2. And I'm just doing the sulfate right now. So that means that the sulfur in this compound, the sulfur is +6. And then for the whole compound to be 0, there's 2 sodiums, each one has to be +1. And then +1 times 2 gives us +2. So each sodium has to be +1. So let's just, I'm going to erase these numbers down here. Now let's just look at this sulfate again. We have -2 times 4 is -8. We have +6. 6 minus 8 is -2. So we're good there. Okay. And then we have, for the positive ion, we have +1, and there's 2 of them, so +1 times 2 is +2. So we have +2 from the sodiums, we have -2 from the sulfate, and that equals 0. See, for this rule up here, right? So this rule about the polyatomic ion, right, that's happening here. That's how we figured out the sulfur has to be +6. So that's basically how this works, and you can do that with any compound using these 2 rules and the rules above. You should be able to figure out the oxidation number of every single element in a compound that I give you. It might take a little bit of practice, but once you feel like you're pretty good at doing that, you should be okay. The last thing I'm going to do is just give you kind of a set of steps that you can follow that you might find helpful in trying to determine the oxidation number of all of the elements. Some questions you can ask yourself. The first one is the substance elemental? Because if it is, then you know that the oxidation number is 0. The second question that you should ask yourself is the substance ionic? And then third, if it's ionic, right, are there monatomic ions? And if they are, then this rule up here comes into play. Right there. Whoops, not too far. Right here. If they're monatomic, then the charges are the oxidation numbers. And then if we look at the fourth rule, um, which elements have specific rules? So you're looking for things, now you're looking for things like hydrogen, oxygen, and fluorine, because those elements have specific rules. So you always want to be on the lookout for those elements in your compounds. And then if there are elements without specific rules, then you have to use the last two that I gave you here to calculate their charges, like I did with the sulfur in both cases, because sulfur doesn't have a rule. So in this compound, the top compound, it was -2, but in the bottom compound, it was +6, and I found that out by using these two rules, the 7 and 8 that I gave to you. Okay, so make sure that you can practice this a little bit. Make sure that you can assign oxidation numbers to all the elements in a compound, that you can do it correctly. And then when you feel pretty confident that, it's probably time to take the mastery quiz. Thanks for watching this video lecture, and as always, if you have any questions, feel free to ask in class.